Welcome, my friends! Consider the expression x squared plus 10x plus 9. Let's say we want to factor this expression into two binomials, something plus something multiplied by something plus something. This is a bit trickier than some of the factoring we have done in other videos, and requires some critical thinking. Let's start with the easy part. We know that we should be able to FOIL our factored form and get back the original expression. So we are essentially trying to FOIL in reverse. That means when we multiply the first two terms together, the f and FOIL, they need to multiply to something we already have in the expression. Looking at our expression, it makes sense to put x as the first term of each binomial, as then when we do the f of FOIL and multiply the first terms, we will get x squared. The other two numbers are a bit more difficult to come up with. Let's call these two numbers m and n. Let's think about the o, or outer, of FOIL, which would multiply these two terms, the x and the n. When multiplied, these will make nx. Let's think of the I, or inner, of FOIL, which would multiply these two terms, the m and the other x. Together, these will make mx. We notice that both our outer and inner multiplications have the variable x, and our original expression contains 10x. That means that mx plus nx must equal 10x, and that m and n together must add to 10. Alright, let's think about our last terms, the L of FOIL. We've already taken care of the x squared with the f of FOIL, and we've taken care of the 10x with the o and I of FOIL. That means the constant of 9 must be dealt with the L of FOIL. That means m times n must multiply to 9. When we do the L, or last in FOIL, we multiply these two terms together. Our missing terms must multiply to our constant of 9. So you can view this as putting together the pieces of a puzzle. Our two missing numbers, our m and n, must add to 10 and multiply to 9. Can you think of two numbers that add to 10 and multiply to 9? I can. The numbers 1 and 9 multiply to 9, as 1 times 9 is 9, and they add to 10, as 1 plus 9 is equal to 10. So our two numbers, m and n, must be 1 and 9. So we can replace our m and n in our factored form with 1 and 9. Our factored expression is x plus 1 times x plus 9. If you want to check your work, you can FOIL it out. The f, or first, of FOIL gives us x times x, which is x squared, just like we wanted. The o of FOIL gives us 9x, and the I of FOIL gives us x, which together make 10x when we combine the two middle terms, again, just like we wanted. The L of FOIL gives us 9. This gives us back our original expression, x squared plus 10x plus 9, verifying that our answer is correct. Now, on that first example, I tried to explain in depth the logic of how to FOIL in reverse. But in practice, you don't really have to think about the logic every single time you do it. You just have to have a process that gets you the answer. Every teacher has their own process of how to easily FOIL in reverse, and I'm going to show you the method I use, which works for me. Let's try to factor x squared plus 7x minus 18 into the multiplication of two binomials. As long as I have a coefficient of 1 on my x squared, my first two blanks will always be x. We'll talk about what to do if you have something like 5x squared in another video. We need to find the two blanks, which I've called m and n previously. From here, I make a chart that looks like an x. We know that the two missing numbers must add to 7, so I write a 7 up here. This is often referred to as the b term, as the expressions we are dealing with are in the form ax squared plus bx plus c, and our coefficient on x is the b term, which is 7 in our case. We also know that the two terms need to multiply to c, which is our constant of negative 18, so I write negative 18 down here. This is our c term, or technically it is a times c, but that only matters if a is greater than 1, which is a topic for another video. Then you just need to remember the rules. We need two numbers that multiply to c, or negative 18, and add to b, or 7, which will be the two numbers you write on the sides. Sometimes the two numbers jump right out at you, and you know it right away. And other times, you might think for 2 minutes and still not know the answer. If you're struggling to come up with the two numbers, I suggest you make a table like this. The first column of the table should list the possible values for m. The second column should list the possible values for n. And the last column should add m and n together. Now you should start listing values in the first two columns that will multiply to c, which is -18 in this case. For example, 1 and -18 multiply to -18. But when we add them together, they add to -17. We need them to add to 7, so that means that 1 and -18 were not the right choices. You can keep trying other options. How about 2 and -9? Well, they do multiply to -18, but they add to -7, which is almost right, but it's just negative. How about -2 and +9? These multiply to -18 and add to +7, so they must be the correct choices for m and n. So we write these two numbers on the side of our chart. Once you get comfortable with these, you might not need to make this table, but it's definitely nice to have, especially when you're first learning. We can fill them into our factored expression, which becomes x minus 2 times x plus 9. If you'd like to, you can FOIL this out, and you should get the original expression back, x squared plus 7x minus 18. Let's try another one. We have 5x squared minus 45x plus 70. Now you'll notice our a term, the coefficient on x squared, is 5 in this problem. If a is greater than 1, the first thing you should do is see if you can factor out a GCF. In this case, we can factor out a 5, which leaves us with 5 times x squared minus 9x plus 14. Now we need to work on just the inside of the parentheses, x squared minus 9x plus 14, and see if we can factor that using the reverse FOIL process we've been discussing. I know my two binomials will each start with x, but don't forget the 5 out front. I also have the two other numbers, m and n. I'm going to draw my chart and put -9 up here and 14 down here. I need two numbers that add to -9 and multiply to 14. The answer might be popping out to you, or you might not know it yet. Again, if you're struggling, draw out a table like this one and start guessing and checking. Write numbers that multiply to 14 and then check to see if they also add to -9. Thinking for a moment, the only way two numbers can add to be negative and multiply to be positive is if we have two negative numbers. If m equals -7 and n equals -2, we multiply to positive 14 and add to -9. So that must be the correct answer. And we can fill in these values to our chart. Our final factored form is 5 times x minus 7 times x minus 2. Alright, let's try one more, but in two variables. We have x squared minus 13xy minus 30y squared. If you were ever asked to factor a quadratic like this with two variables, such as x and y, my advice is to factor it first, pretending there is only one variable, and then worry about the extra variable. This works if you have two terms with just squared values, such as we have here, x squared and -30y squared, and then you have one term that has each variable to the first power. We have -13xy. So the first thing I will do is rewrite the problem without the y terms. So we have x squared minus 13x minus 30. We know this factors to x plus m times x plus n, and we need to find the values for m and n. Drawing our chart, we need two numbers that add to -13 and multiply to -30. I'll give you a moment to see if you can determine what the two numbers are. What numbers add to -13 and multiply to -30? Pause the video and make the table if you need to. Okay, the two numbers are -15 and +2. These two numbers multiply to -30 and add to -13. So our answer is x minus 15 times x plus 2. But remember, our problem had y's in it as well. So all you have to do is put the y's on the constants and you will have the factored form for our expression. the factored form of x squared minus 13xy minus 30y squared is x minus 15y times x plus 2y. Of course, if you aren't sure if your answer is correct, you can always FOIL it out. X squared plus 2xy minus 15xy minus 30y squared simplifies to x squared minus 13xy minus 30y squared, which matches our original expression. Alright, my friends, that finishes up our video discussing how to factor quadratics when your a term is 1. In the next video, we will talk about what to do when your a value is greater than 1.